Hiya, welcome back to the Niagara Learning Channel. This is a continuation from video hash 106, which was the top navigation bar design. This has now been installed on site and I've got to finish commissioning it next Wednesday, but I thought I'd go through some of the items on here and maybe show you something that you didn't know, hopefully. So we've got a main page that we are displaying these crack units, the Denko crack units. These are the backnet points that's coming from these units. There's only unit 4 that's actually switched on at the moment. All the rest, as you can see, have not been commissioned yet, but 4 has been commissioned. So this is unit 4, and we're monitoring the parts per million on the areas that they are serving, and we have basically 3 zones, and the zones are, if I go to the crack backnet, zone 1 is crack units 1 to 4, the open storage area. Zone 2 is the enclosed storage area, and zone 3 is the crack unit 6, which is the viewing stroke workrooms area. So this is basically what a Denko unit looks like, and I just put a nice picture there. I think before I just had a normal graphic, a normal N4 PX graphic, but I thought I'd take a picture across of the unit, and I actually didn't know what they looked like until I went to site, and then I found a picture for it and put it onto the head end. Now this has got a touch screen on site on the MCP1 panel, and what I did with the PDF files, I actually took all the information and all the data files and put them on here so they can click on any one of these and find the information that they want. I added distract zones, so again we've got zones which I've just described to you, like the open storage area 1 to 4, and depending on temperature we will run a fan, supply air into that area. And so those are the zones for that. We've got an anti-Legionella time clock. We've got Legionella valves. If I go back to the home page, these here, anti-Legionella flush solenoid valves. I've put a button so we can actually override them. So that's the button there, north and south anti-Legionella valves, and the blue on here. So that's one of them there, which is closed, and that's the other one there, which is closed. And we flush them at midnight every Sunday. We open them up for a little bit and flush the water through. And then we've got leak avoidance solenoid valves, so if we've got a leak we can close down the water, which is this one here that's feeding these units, and this one here that's feeding these units. We've got an extract fan which is there, and at the moment we're still commissioning the extract fan, so we haven't got, hence that's why we've got the alarm here. We're also conditioning the thyristor units. These are the units that are attached to the Denko. It's a thyristor heater in the ducting, and when the Denko requires heat, this heating signal here on the Denko, when it requires heat, it sends a 0 to 10 to these units, and these units will, along with the thyristor, will operate an electric heater and will heat up in the ducting. Naturally they've got to be airflow, so we only enable them when we've actually got heating, or it wants heating, and we've got the unit flowing through with air. And at the moment we've got a little issue with these. I think we know what the issue is, and I'll sort that issue out on Wednesday when I get back to site. It's just a panel issue, it's just a relay. We believe that we have a relay that enables a 0 to 10 signal from a Denko, and the thyristor unit has an alarm output. Now I believe that the alarm output is, when it's energized, it's not in alarm, it's healthy when it's de-energized, and it's just the wrong configuration on the relay, so that just wants swapping over, and then they will start working and we won't have this alarms coming in here. That's just a common alarm for reception area, so any alarms that happen, we send it to a remote area in the reception area, and it just tells them that there is an alarm somewhere on the system, and then they can go to the front panel and they can actually look where the alarm is and investigate further. What I wanted to show you is these circles here that you see. These are not, and this triangle, these are not graphics, i.e. that they're not image files brought in, they have been just made. And how we do that is, if you go to your kit control, and it begins with B, scroll down and go to this BAJAUI and open that palette. See these shapes here? So I can take this ellipse shape, drop it onto there, and then I can change the shape of it to a small circle. I can change the colour of it to whatever I want it to be, and I can also attach a point to it. So if I go there, not that one, that's just a symbol. If I go there, Control key C, copy that and go to value binding and place that into there, and then I can right click the fill, animate it, so when it's true it's that colour, and when it's, I don't know, we'll just stick another colour in there. So false is green, true is blue. Go OK, OK. So at the moment it is in that colour, but it will change false. And if it was enabled, let's just enable that for you. So that's the leak avoidance ones. Let's just do a, put them on just for a moment. See how that's changed colour now? And of course that's gone open and that's gone open. So let me just put that back to normal. That was off. Now to the logic. So we've got in the logic here, I've got all my inputs. I've got my inputs folder. When it loads up. So they're all my inputs. Mac 36 and Mix 38. And that's it. Not that many really. Yeah, the CO2s there. Outputs, there's not many outputs either. Views, wire sheet. There's my outputs. So I've only got one analog output for the extract fan speed, and these outputs here to enable the crack units, and we've got outputs here to enable the thyristor unit. Once we enable a crack unit, we just enable the thyristor unit anyway. Some D-strap fans here. Those are the 3-zone D-strap fans, and just basic run-of-the-mill outputs. If we look at the logic, so if I go into my fresh air damper enables, I've basically put in here a bit of a DesOps, so I know when I'm looking at it, or I've got a section of the DesOps that relates to this logic, and I've just put nice labels there so I know what units in what area. But we've got a control variable here, which is the CO2 parts per million. We've got a set point, so we want that to be on if it goes over 1,000, and that's the CIBSI rules apparently. Well, they can adjust it to whatever they want. They don't have to keep to 1,000. They can put it down to 800 or less if they want to. Differential of 10, so that's only 5 either way. 5 ppms either way, and that goes out to that AND gate there. Fire alarm, naturally we don't want it running when the fire alarm's on. And then we've got the low ppm, so when we reach 500 less 10, we will basically then switch that off. So we're just reinverting the signal. At the moment it's disabled, and I presume I can show you this working. If I do actions, emergency override, put it to 1100 for example. So that's now enabled. And then if I change it down to less than 500, put that down to 400, that's it disabled. Put it back to where it was. Take the emergency off. So that's showing you that working. Destrap fans. So these are working with temperatures, low level and high level. Same way, but switching on if we've gone above the high level, which the set point for that is 24 at the moment. Again, it's adjustable. At 24 is probably too high. They'll probably be having it around about 21 degrees, and we can set them now. So Manny's saying that we might be starting to put fans on depending on the time, depending on the temperature of the area. Saying that there, I don't think it's that that hot, to be honest, in there, because it's still building walls. So we've got temperatures of around about 19-20 degrees. So yeah, they're not going to switch on if I set them to 21 or whatever. So we can set them in the adjustments if I wanted to. So we've got the set points there in adjustments, so I can knock that down. I can just click on that. It's a touch screen, so sometimes it's better for them to just use their finger or pen and touch on it, but we can also click on that and put it to 21, and we can click on that one and put it to 21, and we can also adjust the deadband as well. So I put a little bit of text here, enabled at 21.5 now and disabled at 15.5, so we can see with the settings that we've done there what is actually going to happen. And I haven't actually shown a temperature sensor, but we're taking the high temperature sensor. I think if I go to destruct zones, we'll see them there. And yeah, there's a temperature sensor there, 19.9, 19.9 and 20. I haven't shown it on the adjustments page, I've just shown it on the destrap page. Maybe it might be wise to show it on the adjustments page as well. So let's take that and that, that and that, that and that, copy, and let's go to adjustments page, see if we can fit these in somewhere. Paste. So zone 1, we really want it, so I'm looking at this bottom one, I just don't want to go too far. So zone 1, highlight that and highlight that. Zone 2, highlight that and highlight that. zone 3. Let's just move them across one more. So now we've got something that we can compare that above to now, which makes that a bit easier, I suppose. Maybe I should do the same with the parts per million as well. Anyway, we'll leave it like that at the moment. So that was the logic for distract fans, which we've just looked at. You can see they're now changed to 21s. Supply and extract vent. Simple enough logic here. Mismatch alarm I would have used there, I would have thought. Waiting 5 minutes. Yeah, so I'm not getting my set point. So because I'm not getting my set point with a differential of 50 either way, so I wanting that to be basically round about 750 if I can, or thereabouts. PA, pascals. And the setting is 0 to 10, 1 to 1600 on the sensors. I've actually put an alarm on because we're not maintaining that pressure, which we won't do because it's not working yet. Leak avoidance, isolation valve, so that's for isolation. These are the overrides that we did. I showed you about overriding the valves. These were just the overrides put in there. That's the time clock for midnight. Next time is 14th of July, which will be a Sunday, and we open it up for 120 seconds. Again, all this is adjustable. And then these are the crack units that, if they're requiring them, they're all going to an OR gate there for the north, OR gate there, and then the south ones there. General alarm, that's just a simple one. It's just bringing in all the alarms and giving you an output. This is a desert, so they asked for it. Crack units, so enable crack unit 1. So once we've enabled the Denko, and if we have any heat that is required and the fire alarm is healthy, we will enable the thyristor. If we don't have any heat, then we won't. And again, that can be adjusted with these thyristor set points. But we will always have our control variable is our temperature sensors here. I think that may change when I finish commissioning the Denkos. I think we will get to a situation where we won't use these at all, and we will just enable them straight through. So we'll take this and we'll put it straight through to there, and we'll take out all this. But I wrote this to how I interpreted the DesOps, but since I've been on site, I realised that the Denko units, the thyristors, you could enable them as soon as you've enabled the cracks, because they won't work until we get a 0 to 10 signal from the Denko. So you might as well just go straight from there straight to in 10 and take out all this. But it's easier to take it out on site than it is to start adding it in and writing the logic. But I will check that out on Wednesday. But I don't think we'll be using this. And then I made a folder just with all the backnet points that I'm taking from the crack units, and I'm monitoring. I have a point there, remote humidifier request from crack 1, but I'm not too sure yet if that works. But I do know that the humidity demand works. So as soon as I've got a 1 there or above, I'm actually that's going to go to true, and then of course it's going to open up the valve for cold water valve for the humidifier for the Denko. So I don't think I have a problem with that. I think that's going to work nicely. I think that's about it. Let me show you the page that it looks like. Let me bring that across. So this is the web view that they can use there on their mobile or their laptop. And if we go into Legionella time clock, all this will work because it's web view. There's your Legionella valve open period and what they are doing at the moment. Adjustments we've seen, PDF files we were talking about. So the panel screen manual. I had to look into this. They've got a Vortex screen, touch screen, and I was trying to change the IP address. So I downloaded the manual and I found that I have to click it 7 times on the bloody screen. So it tells you, where does it tell you? It was somewhere here, and I had to put a PIN number in to change the IP address. So that's the default, which is no good to me. I don't want that address. I'm using 192.168.1, so I'm not using 10, so I had to change that. And it says default screens, there. Here we go. It's got a tip. So you've got to put your 5 fingertips of the same hand, touch them briefly on the screen and remove. Then the Vorex app should appear. In a blank part of the screen, using your finger, tap very rapidly 7 times and the kiosk pin dialog box will appear. If it doesn't appear, repeat and tap faster. And you've got a pin there of 4125 that you've got to put in there. Then you can get into the menus and I can change the IP address setting of the unit so that we can actually see what's going on. We're on the same IP range. So that took about, because I didn't know anything about it, that took me a good 30 minutes of my time to work that one out, to be honest with you. So I'm trying to just find my way back. It's just popped it up in a pop-up. So get rid of that. Wireless schematic. Oh, the thyristor panels I was telling you about. What we think, or what I think is the issue with that, is this 2R1 relay, this alarm. So 2R1 relay, I believe, is energized and it shouldn't be. So what we have to do is swap over the pins. So 2R1 is this one here, which is the overheat alarm, which is not overheated, but that close will send the overheat alarm. 2R1 there will send the overheat alarm on the panel light, and I believe that's going to be the issue. So I'm going to have to change over them contacts and change over them contacts on the 6 panels. So we'll be in a situation where that will be open. That 2R2 opens. There's 2R2 there on the thermal cutout, which is also near the electric heater on the ducting. We expect that to be closed. So I expect 2R2 to be energized. So that will open up that. It will close that. I expect 2R1 to be closed, even if it's energized. I want it closed, and then de-energized it will open, which will energize 2R3, which puts the active light on, and 2R3 here takes this 0 to 10 from the Denko unit. We're converting it from 0 to 10 to 0 to 8 volts DC with this converter rescaler. That will close and it will send the signal into the thyristor unit to then kick out heat on T1, T2 and T3 for the electric heater battery. Simple as that. So I expect that to work when I go back there on Wednesday and change it over. This was the rescaling module that's in the unit for the thyristor, and like I said, it's just taking the 0 to 10 from the Denko and we're rescaling it down to 0 to 8. Crack net, back net monitoring values, so that was all the Denko back net points. Just return air temperature, analog 3, analog 4, cooling demand, heating demand and humidity. So I'm taking all them, and I'm taking that, and I'm taking that, even though I'm not really using it. And then in my digitals further down, and enabling it, the BMS with that one, and I can send a reset to the BMS with that one if it's an alarm. Description of operation, no point in going through it. Panel drawings, well that's the panel drawings for what we've got. Data sheets for the modules that's there, I've put on there. And I think that's it. Floor pan, air differential pressure sensor. As I was saying to you, we are using a PA69906, and if we look further down on here and just blow it up a little bit, we're using the standard range 00, so both them are off. And if we look at the PA69006 with them off, 0 to 1600 PA. And how we did that in the logic is I just did it straight in the folder for the ISMA, and when this loads up, here we go. So there's my voltage, 0.7 volts, and I've just done the 0 to 10 a reset block and 0 to 1600. So just a linear line, depending on what voltage depends on what pascals is coming from there. And all I've done is added in a little bit of logic there, so I can just adjust it that way. I mean, I don't need to go that far. I mean, you can just put the figure in, but I'm not on site, and I know the balancing guys are on site on Monday and Tuesday, so I thought it was wise that they've got access to that so they can change the range if they want to, but I don't think they will. I don't know, or I can just remotely connect in and change it for them. And I think that is it for that. I think we've gone through it all, and you've seen the screen for it all. All alarms, yeah, distract zones, we've done that. Adjustments, I haven't actually put, I know on the station I have put that, but I haven't put this yet on the graphics. I've only put it on the station touchscreen, not on the graphics that's going to the head end supervisor. So I've got that to do, which I presume, no, I can't do it from here because this is just looking at the page. So I'll do that after this video. And there's the home page. So all these that you see, all these circles, these triangles, this are all made via that module that I showed you. Let me go back to this and go to a home page, and we'll just take another one just to show you what I mean. If I take the block there, I've got to delete that one anyway, and then if I want to get a triangle out of that, I will go up to the top here, I'll click that minus, try and get, he says, so as it's highlighted then. Let me pull that back to there. Let me just bring that to there. I've got the right one across, haven't I? Rectangle. Probably not. Polygon. That's the one. Click the minus. Get rid of one of them. Go back to the arrow up there, and then I can reshape this to the triangle graphic. I mean, if I want a diamond, I go back across there, and I need to reshape that to a diamond. No, that's a bit rubbish, but you get the idea. Huh. Probably up a bit more there. You get the idea. That's slightly longer on this one. Bit like that, and then you can rescale it. Alright, so it's a good palette to have, and you can also do tabs as well, which is a good thing. Tab pane. So you can have a tab pane at the bottom, and you can have, say, one tab will be for the time clock, one tab could be for a graph, one tab could be for adjustments. And you've got your tabs up here, you just click it, there's your time clock, click it, your adjustments, click it, your charts. So it's worth playing with this palette if you get time. And if you want a simple circle, I mean, you can see, I think, if I go to my extract fan, see this little green bit here. Well, that all that is doing is, that's not a run and a stop, that's a fault. So if it ever goes faulty, that will then go red. So it's just a little indicator that, in fact, I can do that for you, can't I? If I go active, and we'll just set it custom, and we'll set it for 10 seconds. So it's gone red there now. Yes, I've also put an X on there as well. So if it goes into alarm, it will basically sort that out. Okay, I think that's it. I don't think I need to go through any more. We've got the little name of who's logged in. Up here I've got adjustments as well. I've got the time clock. I've got information bar of what they all mean, like a key. I can press that and log out. I can press that and go to my home page. Outside air temperature, I can click on this alarm bell and it shows me what the alarms are. So if I click on that, so we've got 6 alarms. Oh yeah, because I'm not on the internet. So if I go to the internet page 1 and I click on, if I refresh that, it's only 2 anyway there, showing that. And there's your extract fan below pressure, and that was a general vent fault extract, which is now healthy again. I can just highlight them and acknowledge them. Right, I think that's enough. So thank you for watching. If you've learnt something or not, can you still subscribe? Thank you very much. Bye.